The first thing that we want to do for our mini project is to attach all the packages we're going to require. So we're going to require the deploy package. Then after that, let us define this data set, which is for the financial budget. And we are going to read this data set. So this data set is financial budget.csv. So let us look at the head of this data set. Now, if you can look at all the columns that we have this column X, we have department, and we have the funds allocated. However, we are not going to need this column, which is X. So it's best to just remove this column. There are tons of ways, of course, in which you can use, but we are simply just going to use deploy package. So now what we are going to do is we are going to say in this data set, what we want to do is we want to use the pipe operator, and we're going to say select. Okay, then we simply just pass in negative X. This simply means we are removing this column X. And if you run this, now let us look at the head of this data frame. And if you run this, and now we can see that the resulting data frame does not include that column that we didn't need. We simply have the department and the allocated funds to that department. Now let us check if we do have the missing values. So if we come in here and then we pass in this data frame, so we can see that this data set has the missing values, right? So if we can say maybe tail of this data set, and if you run this, so you notice we have these NA values. So what we can do, because we simply just have one row that contains the missing values, is to simply just remove these missing values. And in order to do that, we are going to use the omit function. So we're gonna define this data set again, and now we're gonna say an a.omit, and then we want to omit all the NA values in this data set. And if you run this, now if you say the sum of all the missing values, you can see that it is now 0. So we've managed to remove all the missing values. So if we come also here and say let us sum and see if we do have any duplicated rows in this data set. So if you pass in this data set, and if you run this, so we can see that we are fine in terms of the duplicated rows. Now what we want to do is we want to have an insight of the allocation of these finds. Okay, so in order to do that, let us simply create a barplot, and on that barplot we are going to use this data set, and what we want to do is we want to look at the funds that are allocated. So let's try to run this. Now this here is the barplot that shows the funds allocated. But now if you can observe in this barplot is that we do not have the labels in the x-axis. So how can we do that? So in order to do that, we want to be able to see different departments. Okay, so if you come in here and say in this data set, and you say department, and if you try to run this, so you can see that this here is not returned in the form of a vector. Remember, names.arg argument requires that whatever we pass into that argument to be a vector. So we have to convert this into a vector. So how can you do that? So if we come in here and we say for example, we save name and we say as dot vector. And if you run this, now if you say name, so you can see now this here is now returned as a vector. Okay, so we had to first convert this into a vector. Now, if you come in here and say in this barplot and you say names dot arg, So we're going to use this argument and we pass in name. And if you try to run this, you can see now it's showing the different departments. Okay, now what I'm going to try to do is I'm going to try to change the orientation of these mark labels. Okay, and in order to do that, I'm going to come in here and I am going to add this argument. Okay, so in this argument, we want to pass in a value. Okay, so in order to change the orientation, so if we pass in 1, so this indicates that this is always horizontal. But what we want to do is we want to pass these to the value of 2 to indicate that we want these labels in the x-axis to be perpendicular. Okay, now we are seeing that we are also having a little bit of a problem. Okay, because these labels are now not clear. So what we want to do is we want to use the par function in order to be able to control or set the margin sizes. So how can we do that? So if we come in here and say par function, and then we want to say in this argument, so this argument controls the margin sizes. Okay, so if we come in here and we pass in this vector, inside this vector, we are going to set the margin size in the order of bottom, left, top, and right. So we have to pass in a vector with length 4. So let's say in this case, we pass in 23, then we pass in 6, and then we pass in 4 and 4. So now if we set this to 23, we are saying that here at the bottom, the margin size is set to 23 so that we are able to see these department names. Okay. And then if you run this, now we come in here and we make a plot. So you can see now that we are able to see all these names. Okay, so what we simply did is we simply just wanted to set the margin sizes, and at the bottom we had to pass in 23 in order to control the size of the margin here at the bottom. We also want to add in the legend. Okay, so how can you do that? If you can remember is that we have certain arguments, right? Such as legend.text. And for legend.text, I'm going to use that vector of name. So we simply just use the departments. Okay. And then we also want to have this other argument. And then in this argument, we pass in the list. So for example, we want to control the size of the text inside this legend. And we also want to specify that we want this legend to be top right. And if you run this, now we have this bar chart. It now have a legend. So what's left to do is for us to add different colors. In order now to add colors, I'm simply just going to create a random colors. And I'm going to use this function randomColor from randomColor package. So simply here, we are simply just creating random colors. So if we say count, it's the number of random colors that you want. We want 10. And if we say hue, I'm going to say blue in this case. Okay. Now, when we come here in this plot, and now I say I want the colors, and I pass in this vector of colors. And if I run this, now we have a clear indication of which color belongs to which department. Okay, so if you can see here, we have did that by passing in these random colors, and we have set the hue to be blue. So we now have this mixture of colors. From this bar chart, what we can see is that the finance department, look at this department, Ministry of Finance. So this is the department that is getting the most of the share of the total budget. So this is what we can see from this bar chart. But now we also want to add the xlabels. So how can we do that in this case? Remember, we have set out the margin size. So how can you do that in this case? So the best way, because you have set the margin size, is to use the function title. Now we want to use the title function. Okay, so in order to use the title function, we are going to say main, and then here we are simply just looking at the financial budget. Okay, and if you run this, so we have added this main title. What we also want to do is we want to add the xlabels. Okay, and on the xlabels we have the department. Additionally, remember that we have set out the margin. So now the margin is different, it's not the default. So we also have to specify an additional argument, which is MGP. Okay, so this argument allows us to set the xlabel location relative to the edge of this inner plot window. Okay, so in this case, we're simply just going to pass these numbers to try and place the xlabel on the right place. And we're going to pass in 0.9, and I'm going to pass in 0. And if you run this, now what you can see here is that we are simply not able to clearly see the xlabel. So if we come in here and let us have a plot of this, and let us add colors, and let us add the main title, and we are going to now add a different vector. So we're going to have a different values for this vector. So let's pass in 23, let's pass in 1, let's pass in 0. Let us see now. So with 23, 1, 0, we were not able to see department. However, if you play around with the values of this vector, the most important one is this 21. So if you change this to 21, 1, and 0, you will be able to see in this bar plot, now we have added department, all right? So as our label. And also we can do the same for the Y label. So if you come in here and you say the Y label, so in the Y labels, what you have is you have the funds. So the allocated funds. And we also want to control that, and we pass in this vector. So now let's say 4.9, 0.9, let's use 0. So the same one that we tried to pass on the xlabels. So you can see now that funds is showing clear, department is showing clear. We also have the main title. We have also added the legend. So in this plot, as we did mention before, that we're simply just looking at this financial budget, in fact the allocation of the funds in different departments. So now we were able to see and visualize using a bar plot to see that the Department of Finance is getting a lot of funds, and following is these other departments. Okay, so we can see here that the Department of Education is not getting much funds. Now, let's say we want to have a clear indication of the distribution of these funds. So the best plot that you can use in that case is a pie chart. And if we come in here and say, what we want to do is we want to look at the allocation of funds. And if you run this, so here is this pie chart. Now the work starts. We need to customize this plot. Now we're first going to start by setting the margin. So if we come in here and now we say, let's say for example, we pass in this vector and say 26, 4, and let us keep these two the same, and let us look. Now let us draw So you can see now it's showing a little bit much better. Now the first step is, of course, to try and add the percentages in this pie chart. Okay, and then we add the colors. So the first thing that we want to do is we want to define the percentages. So if we say PCT and we say we want to round these percentages, of course, and we say financial budget and we say funds allocated and we divide by the sum. So here we simply just want to calculate the percentages and we divide by the sum of this column funds allocated and we multiply this by 100. So we have managed to calculate the percentages, and we also want to add the labels of all these percentages. And in order to do that, we are going to say paste, and now we want to be able to see the department. So in order to do that, we're going to say financial budget and we're going to say department, and then I'm going to add, and I'm going to clear the console, Control L. And now what we want to do is we now have added the department. We want to secondly add the percentage, and then we want to add the percentage sign. So this is simply just a paste function. And if you run this, now we are ready to create this pie chart by adding in the percentages. And then we're going to say labels, and we want to pass in label that we created here. So this is the variable that we are going to use. And after that, we run this. Okay, we are getting an error because we forget to specify that it's the funds allocated. And if you run this, and we are able to now see, using the pie chart, the distribution of these funds. However, you also notice that you might also need to try and zoom this a little bit so that we have a clear visualization. Okay, so now if you can look at this pie chart now, we're able to see the total distribution of the funds in each department. So you can see that the Department of Finance is receiving about 40% of the funds, while the Department of Education is only receiving 3%. Okay, and following is here, the Department of Consumer Affairs is receiving 7%, and the Department of Defense is receiving 14%. So it seems like based on this financial budget, more funds are being spent on defense rather than education. So you can see, and also there are not so many funds that are spent on agriculture as well as road transport and highway, and also the development of rural areas. So you can see here, rural development is only receiving 4% of the funds. So it seems like the Department of Finance or the Ministry of Finance is receiving most of the funds. So let us also go ahead and try to create random colors. So in order to do that, I'm going to try and minimize this. Okay, we're going to get back to it. And now let us try to create this random vector of colors. So I'm going to use random color, and I want this to be 10. Now let's say we say hue, and let us say now we use pink, and let's run this. Now if we come here inside pie function and we say the color should be colors, okay, and let us add the main title, and let us say here we are looking at the distribution of funds. And if you run this, and now just look here, we have managed to change the colors and add this main title. So you can see here, based on the random colors, we set the hue to be pink. So the colors, they are taking mostly the pink color. So that is the combination that we are seeing. So we have looked at the distribution of funds in these main departments, and we have observed that about 40% of the funds are being spent on Department of Finance. Following is these other departments, but if we were to look at the main departments, is the Department of Defense or the Ministry of Defense that's received the second highest portion of the funds.